Good afternoon, good morning, wherever you are joining us from in the world, and welcome to this seminar 1 year on What Have You Learned? What have we learned? Properties of low sulfur fuel oils. Thank you for joining us today. This seminar will be recorded and made available on our website, and a link will be sent out to all those who've registered so you'll be able to share it. Our presenters will make time for questions at the end. So if you have any questions at any point during the presentation, please just type them into the chat and one of our presenters will get through as many of them as possible at the end of the presentation. So today you'll hear from Paul Gunter. He's the OSRL consultant. Paul has 30 years of experience working in the industry and has worked with numerous operators, regulators, and governments on a wide range of projects globally. He's written a number of papers and presented at major conferences, sharing his knowledge of the behavior of response mitigation of heavy oils and emulsified fuel spills. He's a member of the Royal Society of Chemistry. Within OSRL, Paul is a project managed and delivered IMS compliant oil spill contingency plans, exercises, and capability reviews for offshore and inland operations around the world. You'll also hear from Celia Berger. She's from the Norwegian Coastal Administration, called NCA. Dr. Silje Berger is a project manager of the EU co-funded Immerse Project on behalf of the Norwegian Coastal Administration. She's a senior member of the Oil Spill Response Organization at the NCA, and she's been involved in response operations, contingency planning, and research and development projects, lately especially in the field of low sulfur fuel oils. Celia is a trained biologist with a doctoral degree from the Leibniz University in Hanover, Germany. And finally, we'll hear from Fanny Chever from Cedre. Dr. Fanny Chever is a research scientist at the Analysis and Research Department of Cedre. Involved as a chemist, she works on laboratory and pilot scale tests to study the behavior and fate of oil spills at sea. She's also involved in identifying the origin of oil spill pollution incidents, and she's a lecturer in training courses for civil servants as well as industry, and is a member of Cedre's emergency response team as an appointed duty engineer. She's in charge of the WP3 chemical characterization of the EU co-funded Immerse Project. Fanny's a biochemist with a PhD applied in oceanography from the Institut Universitaire Européen de la Mer in Brest, France. Without further ado, I'll now hand you over to Paul Gunter.
Thank you very much, Mandy. Good afternoon, everybody. My presentation is based on 5 different parts. I'm just trying to get the pointer working, if you can just bear with me 1 second. Okay, there we go. I'll give you a very brief introduction to start off with, say a few words about OSRL before setting the scene. And then moving on to the main thrust of the presentation, which is talking some more about the low sulfur fuel oil properties and also the implications in terms of spill response. We'll then wrap up with some conclusions and next steps. I've put the questions at the bottom there, but as Mandy's just said, we'll take questions after all of the presentations at the end of the session. So thanking you in anticipation. Okay, just a very quick introduction to oil spill response, just to say a few words about OSRL in the introduction, but also to look back at the first webinar that we gave back in November. This is actually the second webinar that's been organised by OSRL. The previous one included an excellent presentation by Sintef that explained the weathering properties of new generation low sulfur fuel oils based on work that had been undertaken up to that point. And it was clear from the ensuing discussions that there was a lot of interest in the topic and certainly a lot of questions. What we'd like to try and do is to build up and from that previous seminar, but in a sense also take a step back and look more closely at the properties and characteristics of low sulfur fuel oils based on data that's been gathered through 2020. I hope you find today's webinar instructive, informative. This is very much about dialogue and collaboration, and hopefully we can continue in that spirit. Just a very few words about oil spill response. I think most of you probably know who we are. We're the largest international industry-funded cooperative out there, owned by the major oil and gas production and transportation companies. OSRL has a mission to prepare and respond effectively anywhere in the world, and that preparedness includes oil spill contingency planning exercises, training, also includes things like emergency response and crisis planning as well. And as you can see from the picture on the bottom of the screen there, we are also very much involved in subsea well intervention services. There's a capping stack there, and things like equipment hire and salvage. You probably will recognise a lot of the logos here. These represent the participant members that OSRL has, some 39. And as I say, you probably will be familiar with most of those. But also interesting is the fact that there's some 117 associate members, and those associate members are very wide-ranging. They could be energy companies, but also include refineries, port authorities and other government agencies. So the membership is a very broad base indeed. I'm not quite sure if that includes the new shipping category membership, but that's something I'll check after this webinar. In terms of OSRL's footprint, there are a number of different bases. Here in the UK, we have the main one at Southampton, but also Fort Lauderdale, Bahrain and Singapore. And you can also see that there are 3 regional offices and a number of subsea well intervention service bases. So a very global footprint indeed. Now, as I mentioned earlier, this is the second webinar, but before we go any further, I just wanted to acknowledge that there have been some other very good webinars out there, and I'm thinking particularly of those that were organised by the UK and Ireland Spill Association that focus particularly on the MV Waukesha, the spill in Mauritius. There were some very good guest speakers indeed from CFAS, amongst others. So I just wanted to highlight that fact that there's some other good stuff out there as well. In the first webinar, OSRL and SINTAF presented, and I'd like to draw on 2 specific things from that first webinar. Firstly, what we're talking about when we refer to low sulphur fuel oil. And this is a slide that I borrowed from Per Darling's excellent SINTAF presentation in the first webinar, so thank you, Per. And this basically shows, or will show, that when we talk about low sulphur fuel oil, we're not talking about one single thing. On the left-hand side here, you can see the different marine distillate fuels that can be found. And on the right-hand side over here, we have the marine residual fuels. When you think of marine gas oil, marine diesel, you can see where they sit within the distillate fuels. And when we think of the heavier, more traditional heavy fuel oils, the IFO 180, IFO 380, this is where they sit in the great scheme of things over on this side of the residual fuel oil specification. But when we talk about the new generation low sulphur fuel oils, we can see what a broad spectrum, what a wide range this potentially encompasses. And we're talking low sulphur fuel oil, ultra low sulphur fuel oil and very low sulphur fuel oil here. But clearly you can see it's not a single entity, it's not a single thing, and not one amorphous substance, as we can see from that particular slide. The other thing that I wanted to show you was that in the first webinar we had many questions, and this is a collection of those questions, and I wanted to reassure people that your questions don't just disappear into a black hole. We do make note of the questions. Obviously we try and answer as many as we can during the webinar, but there were so many last time that wasn't possible. But I have been all through the questions, and I was able to break them down into 4 different categories in terms of response, questions about behaviour, questions about environmental impacts and other. And most of those other questions related in some way, shape or form to collaboration. And clearly that's what we're trying to do in this series of webinars, is to build upon that. Now, we've tried to take account of these different questions in my presentation, but also that's one of the specific reasons why we're so pleased to have the Norwegian Coastal Administration and Cedre talking about the work that they are currently doing, because it does touch upon all of those subject areas. So I just wanted to say that before we get into the main thrust of the current presentation. Okay, so what I'd like to do now is just set the scene, if you like, and establish, when we talk about low sulphur fuel oil, how big a deal, how big an issue is it? In terms of volumes, there are various figures you can get from different sources, but a figure that I found from the International Energy Agency was that around 221 million metric tons per year was the figure that was indicated. And I've got a couple of graphs here on the right hand side, courtesy of the International Bunker Industry Association, or IBIA, who I thank for this information. And this top graph here represents the bunker volumes in Singapore. Now, Singapore, yes, it's only one location, but it's a very major bunkering hub. And what this basically shows is that despite the very tough situation in 2020, that bunker volumes have more or less held up. Now, as I say, this is only one location, but if you assume that the average is around 4 million tonnes per year, you can see that Singapore represents around 20% of the bunkers market, so a very significant player indeed. And the figure below shows basically that when very low sulphur fuel oil was introduced with the new IMO regulations at the beginning of January 2020, take up has been very high, and that's the orange band that you can see down the middle here. So again, I've seen figures from different sources, but on average ranging from a 55 to 70% take up of low sulphur fuel oil, a very low sulphur fuel oil. And this brings us again to this point on the left, that when we talk about low sulphur fuel oil, there are different types of low sulphur fuel oil. Our focus for the rest of the presentation will be on the very low sulphur fuel oil category, and that, as you can see, represents a very big proportion of the bunker volumes. But let's not forget, and this is something that we need to be mindful of as in terms of spill response and preparedness, that there are other fuels that could be carried as bunkers. This presentation is more about low sulphur fuel oils, but from a holistic point of view, we shouldn't also forget that there are other more traditional heavy fuel oils that will still be carried, because vessels could be fitted with scrubbers. There are other means of compliance with the sulphur regulations that were introduced in 2020. So it's just to make sure that we keep our eye on the ball, that we are prepared for all scenarios. I'd like to now talk a little bit about the properties and the characteristics based on the results that we've collected together through 2020. And I'd like to pass a very big thanks to VeriFuel, Rob Leventhal, who very kindly shared a lot of data with us, was very sympathetic to my numerous requests. So thank you to them. And basically what we have here is I focused on some of the parameters that are of particular relevance from an oil spill perspective. The tests are according to ISO 8217, and as we supposed, as we thought, the results have confirmed that there are a very broad spectrum of results and properties with the very low sulphur fuel oils. Now, I've concentrated on three parameters here, which are viscosity, density, and pour point. We have information for very low sulphur fuel oil, but I've also included some information for high sulphur fuel oil and marine gas oil, just as a comparison, just for context. I'm sure most of you know what these properties are, but the viscosity is basically the internal resistance to flow. How easily does a material flow? Is it liquid or not? And the one thing to note there is that the viscosity is quoted at 50 degrees Celsius. So that's something to keep in mind as we go through this data. The pour point is the temperature at which the oil ceases to flow. So from an oil spill response perspective, you like to see a low number, because that means the oil is staying nice and liquid even at low temperatures. So above the pour point, the oil stays nice and fluid, nice and liquid, but once you approach the pour point, the oil can become much more viscous, and it can even solidify and gel. So that's a very important parameter. And the density is basically an indication of how likely the oil is to float or to sink in simple terms. And if we look at those viscosity figures, we can see for the low sulfur fuel oil that the average figure from data collected through 2020 was around 107, 108 centistokes. Now, the real interesting thing is, though, when we look at the range, the minimum value of 2.2 and the maximum of almost 700. That is quite a significant range of viscosity results. Just again for context, water has a viscosity of around 1 centistoke at ambient temperature and around 0.5, 0.6 centistokes at around 50 degrees C. So, as I say, just for comparison, you can see that is a very low viscosity when we talk about the minimum. And again, you can see that the heavy fuel oil and the marine gas oil sit within that range of results that we've collected for very low sulfur fuel oil. Similarly, for density, we have quite a range here that is up and over 1,000 and right down to 828. And again, heavy fuel oil and marine gas oil are encompassed within that range. Also very interesting are the pour point results. What these results show are that 70%, 77%, almost 3/4, have a pour point of less than 21 degrees C. But that means that around a quarter, 23%, have a pour point of 21 degrees or higher. And again, if you look at the range, that's a very wide range from right down as low as -33 up to around +39 degrees. So, you know, that is a very, very wide range. And I think one of the key words that we see here is variability. I'd like to explain that a little bit more, but before we do, I've just put up some other data here at the bottom of the screen from 3 significant spills that have happened in Europe in the not too distant past: the Erika spill, the Baltic Carrier, and the Prestige. And again, I've included density, viscosity, and pour points. So just so that you can see that with these oils, where they sit, and they sit towards the upper end of this maximum figure of 690. So 555 for the Erika, 611 for the Baltic Carrier, and 615 centistokes for the Prestige. But for me, what's also very interesting is the pour points. If you look at the pour point from the Baltic Carrier spill, that's around +18 degrees C. And when that actually hit the cold waters off the Danish coast of around 5 degrees C, the oil took on a chewing gum, a more viscous character, because it was below that pour point. So, you know, I just point that out because I think that's a particularly interesting feature and makes it slightly different from the Erika and the Prestige, which had lower pour points. So I'd just like to look at the viscosity and the pour point data in a little bit more detail. And what I've got on this particular graphic is a set of viscosity curves on the left-hand side and the pour point data on the right. If we focus first on the viscosity data, what we have is a series of different suppliers from different parts of the world that show how the viscosity varied throughout 2020. So if we start at the bottom left here with supplier 4, we can see that the viscosity is actually pretty low, pretty stable. You'd wonder what all the fuss was about. There's a slight variation towards the end of the year, but by and large, pretty low, pretty consistent. And the same story with supplier 5 here. There are a couple of peaks and a bit of an upturn here, but generally a pretty consistent viscosity throughout the year. But then when we contrast that with supplier 1, supplier 2 and supplier 6, we can see a much more varied picture. We can see viscosities from this example down around 20, but also up over 300. Interestingly, we get the same picture with this supplier 2, and for me also very interesting is supplier 6, because supplier 5 and supplier 6 are both Singapore. But whereas with supplier 5 we have relative low and consistent results with viscosity, for supplier 6 we have a much more varied picture that can vary considerably from operation to operation. So same parts of the world, but a very different picture. So again, I think that is just a snapshot, but it just shows that there are some interesting geographical as well as temporal variations in viscosity. What we have here on the right hand side are 3 graphics of pour point. The first and top one is for the first half of 2020. The second one is for third quarter, and the third one below is for the fourth quarter. And you'd expect broadly the same pattern, and as we highlighted on the previous slide, around 3/4 have a pour point less than 21 degrees C. But I just wanted to show you some of the other data, and you can see that there's quite a significant amount of samples that have pour points of 21 and 24 degrees C. And even don't forget the Baltic Carrier, that had a pour point of 18 degrees C, and that's still when we had a spill in cold waters of cold European waters, gave us some challenges and issues in terms of the behaviour of the material. So again, I just wanted to illustrate that just because it's less than 21 degrees, that doesn't necessarily mean you're out of the woods, but you can see that if you had a spill and the pour point of the oil was 21, 24 or 27 or 30, there is a very good chance that once it reaches environmental conditions, you will go below that pour point, and then the oil will change in its character. Now, when we have an oil spill, the oil starts to undergo a series of processes collectively known as weathering. And these can change the amount and the character of the spilled oil. Some processes like evaporation cause a reduction in the volume of the oil. Other processes such as emulsification can cause an increase in the volume and also the viscosity of the pollutant. Basically what is happening is that small droplets of water become emulsified and a stable water in oil emulsion is formed. This can in some cases be up to 80% of water. So you can think that is a very increased bulk. You're bulking up the amount of pollutant. I mean, there's an adage that no two spills are the same. The size of the spill, the type of oil, the environmental conditions, the location will all combine in a unique way to affect how the oil behaves. But from an oil spill responder's point of view, you obviously want to know as much about the oil as quickly as possible. And there are a number of parameters that I've listed down the left hand side here that you would like to know that tell us how the oil is likely to behave. There's a very good IPCA IOGP document that I've indicated here that provides more information. But the reason I mention all of those parameters is because you will recall that when bunkers are tested according to ISO 8217, we don't automatically get all of those things that we want. We got density, we got pour point, we got viscosity, but that viscosity was at 50 degrees C and not at the environmental temperature that we would encounter following a spill. And we've already seen that if you have an oil that has a relatively high pour point, it can be nice and fluid at 50 degrees C, but that's not the full story. So, you know, again, I wanted to make that point. We want to know as much as possible, as quickly as possible, but it's a question of how much of that data will be readily available. Now, obviously, this has implications when we consider the spill response itself. We've already seen that there are very wide-ranging viscosities, a wide-ranging pour point, and clearly oils with different properties, different characteristics are going to have different potential impacts. You're going to need different equipment for different types of oil. So an oil that has a viscosity of 5 centistokes potentially is going to weather and behave very different to that oil which was up around 700 centistokes. It's not a case of one size fits all. In the excellent Syntef study from 2019, they tested 3 different samples, and those were up at the upper end of that viscosity range and also around the average. I think one of the samples was up around 600 and 2 of the samples tested were around 100. So it's just interesting to note that the lower end of that viscosity range wasn't considered in the previous study, but I'm sure it will be in forthcoming studies that Celia and Fanny will talk about. So we've seen very variable properties. We've seen that some very low sulfur fuel oils could be high viscosity and are likely to emulsify as per the previous Syntef study. And this is just another opportunity to remind ourselves that, don't forget, the bunkers may not just be very low sulfur fuel oil. It could be vessels fitted with scrubbers, and we do need to be prepared for those more traditional heavy fuel oils. And there's been a lot of work carried out. This is a slide put together by ITOF. And I know when I used to work with emulsified fuel oils, we did a lot of work on mechanical feeder skimmers and response options that are most suitable for those more viscous oils. So there has been a lot of work undertaken over many years. This is actually a picture here from the Baltic carrier spill, the one that I mentioned earlier. Not very sophisticated perhaps, but probably very effective given the nature and the characteristics of the oil. When you have a viscous oil like that, the least handling you have to do, the better. So I think that's just an interesting point out there, that there's a lot of work that has been done on these heavy oil skimmers in the past. But what we also know is that many of the very low sulfur fuel oils are much lighter. If we think of the MV Wakashio in Mauritius, for example, we've seen that some of the oils may be low in asphaltenes, may not emulsify and weather to the extent as we think about, or we used to think about when talking about fuel oil. In that particular case, the oil stayed of a very low viscosity for many weeks, and the type of skimmers that were working very well were skimmers that were suited for low viscosity oils. So some of the oils will not necessarily be the viscous oils that we used to think of with heavy fuel oils. So if we look at this graphic here, we can see we have it's a plot of viscosity throughout the year, but if we look at the grey band and below, we can see that approximately 50% of the very low sulfur fuel oils have a viscosity of 80 centistokes or less. So, i.e., around half are not that viscous. So that's an important factor to bear in mind. And we also need to bear in mind that very low sulfur fuel oils directionally may also be potentially waxy or paraffinic. And these are the materials that tend to cause the gelling with pour point. So we may find a possible temperature dependence. We may find that at warm temperatures the oil will be nice and fluid, it can pour, it can flow. But once the temperature drops, we may find that the oil takes on a more solid or gel-like character. And again, we have seen previous examples within the industry, the Baltic carrier spill, waxy crude oils, waxy condensates. So it's not to say that we haven't had these things in the past. And there may be some rare circumstances that we may see that there could be separation of lighter and heavier components. As an industry, we're used to dealing with blended products. Heavy fuel oils were bottom of the barrel materials blended with different amounts of cutter stock to reach a particular viscosity. So again, that's not particularly new, and we might see similar things with some very low sulfur fuel oil spills. But again, that's the type of behaviour that we've seen with other substances in the past. And all I think I'm trying to do with this particular slide is to highlight the variability. They're not all of the same. So that's, from an oil spill response perspective, something we have to take into account. This next slide, I've got a tier preparedness wheel over here. So when we think of preparedness and response, we take into account a number of different capabilities. There are 15 capabilities shown on this wheel here. But again, interestingly, if you look in the centre, there's IMS, or the Incident Management System, and it's probably a good time just to remind ourselves that you can have all of the equipment and lots of manpower, but if you haven't got the right organisation in place at the start of your response, then you're going to struggle. So I just wanted to point out that we often focus around the different components of the wheel, but let's not forget what's at the heart of the wheel as well. What I've done on this left-hand side is to sort of pull out some of those different components, and we can just talk a little bit more about those. Now, if we think of containment and recovery, well, we've already seen that the very low sulfur fuel oils could be very different. You'd want to know at an early stage what you're dealing with, because you want to know which tools from the toolbox to apply. Not all skimmers work with all oils. So which type of skimmer would you need to use? Would you need to worry about viscous oil transfer or not? So that will be very much determined by the viscosity of the oil and how it weathers. But clearly you may want light disc skimmers for the lighter oils, but you may want mechanical feeder skimmers and need to take into account of viscous oil transfer for the more viscous materials. We do know that with the more viscous materials, that getting it off the surface of the water is just the start of the challenge. Once you've recovered it, you've still then got to transport it from point A to point B. So all of the planning, all of the infrastructure for that needs to be considered. I think a lot of people also thought that maybe dispersants would not be an option for low sulfur fuel oils, but we've seen that 50% of them at least have a pretty moderate, pretty low viscosity, so it may well be that dispersant spraying would be an option. Skimmers, dispersants are formulated to work on a wide range of different products, but it may be that a test spray out in the field will be the only way to actually definitively determine whether the dispersant would work or not. And obviously with all of these different capabilities, we would be guided by NEBA and SEMA net environmental benefit analysis and spill impact mitigation assessment. They would help determine which of these tools are most suitable in a given situation. And it may be in some cases that the dispersant would in theory work, but if the water is too shallow or if you're too close to shore, then it's not an option that you would consider. But for spills that are offshore, then dispersant spraying may well be an option. Also, the characteristics and properties of the oil will have an impact on how the shorelines are affected. So, we know that heavy fuel oils can have a disproportionate impact on shorelines. The way an oil behaves will affect the quantity that comes ashore. It will affect the viscosity, the persistence of the oil, the time taken to clean it up, and also the cost. So you can imagine a very light oil with light ends that might evaporate is going to be very different to the oil that is much more viscous. Also, environmental impacts. We've seen that some of the very low sulphur fuel oils are more viscous than others. Some will have some of the lighter components, and chemically that will potentially vary quite significantly. The heavier the oil, the less BTEX and bioavailable PAHs that the oil is likely to contain. The BTEX will tend to evaporate quite quickly. The benzene, toluene, ethylbenzene, xylenes, they are the more toxic, very toxic, but also very volatile. The 2, 3, 4 ring PAHs are the ones that tend to be more bioavailable. And directionally, you do tend to find that the heavier materials tend to have less of those bioavailable PAHs. I've worked with some very, very heavy asphaltenic materials in the past that from a chemical point of view were essentially chemically inert because they were more or less ball bearings. That does give you a physical challenge, but from a chemical perspective, it means that there wasn't much that was actually getting into the water column. But the environmental impacts, the amount of BTEX and PAHs is something that would need to be considered in the post-spill monitoring side of things. And there was some good presentation material by CFAS in one of the previous webinars where they talked about the approach that they implemented in Mauritius. And there was a lot of good work undertaken in the United States following the Macondo spill, not suggesting a bunker spill would be of that same magnitude, but there was a lot of robust work that was undertaken in terms of when fisheries should be opened and how they can be reopened. So it's just to say basically that these low sulphur fuel oils will not all be the same, and there is therefore going to be a need to implement monitoring following a spill. So in conclusion, are all very low sulphur fuel oils the same? No, definitely not. Definitely not a case of one size fits all, and I think it would be wrong to adopt such an approach. I think we do have response tools in the armoury, but we need to know which ones are most appropriate, and of course we would be guided by NEBA and CEMA. I think for this second bullet point here, I think this is very important to bear in mind, because if you have response inventories, if you've got equipment, if you've got standby operations, you want to know which equipment you should have and what its range of capabilities are to make sure that you're adequately covered. I don't think we need to start from scratch. We're not reinventing the wheel. A lot of work has been done, for example, with mechanical feeder skimmers. What we need to do is not to make any assumptions. We need to make sure that plans are fit for purpose. We need to make sure training and exercises are conducted. But this final bullet points, we certainly don't have all of the answers. There is a need to verify, and there's always a room for improvement and learning. the spill that took place with the MV Wakashio, the lessons that we can learn from that, for example. And I found myself that industry has usually been very supportive. When I was doing a lot of work with heavy oils and emulsions, we did some work at Cedre in their test basin, and Lamore came along. They brought their brush skimmer, and whilst the oil picked up the bitumen, we found that it was actually very, very difficult to get the oil off the skimmer. They went away, did some work themselves, and lo and behold, they did a lot of good work to actually optimize the removal system from their brush skimmers. And similarly, we did some work with Desmi, where they did some good work on skimmers, but also viscous oil transfer. As I mentioned earlier, once you've recovered it, that is just the start of the challenge. You've then got to transport the oil from point A to point B, and transferring that oil through narrow hoses over long distance is a very big challenge. But Desmi certainly did a lot of good work on those viscous oils that has enhanced our response capabilities, and that wasn't just for us. There was a lot of good work undertaken for the US Coast Guard, the Canadian Coast Guard, amongst others. ERE, they developed a refloater that was a very good tool, and there is one of those that's sitting in the OSRL stockpile for refloating emulsified fuels. So it's just to say that I know in the past industry has been very supportive generally of these things, and I'm sure that that will be the case with very low sulfur fuel oils moving forward. In terms of next steps, well, the OSRL's internal knowledge gathering and internal sharing is currently ongoing. We are very keen to maintain this dialogue and collaboration through this series of webinars, through talking to people like Norwegian Coastal Administration and Cedre, but also with other governments and industry bodies as well, because it does have an impact in terms of preparedness and response across the board. The Immerse and the EPR PAIN projects are ongoing, and you'll hear a little bit more about those in the next presentations, as are other potential R&D projects. But as I mentioned above, there are lessons that we can learn, and we need to take those into account. For example, that CFAS post-spill monitoring that I mentioned, and the US work as well following Deepwater Horizon. And of course, what we'd like to do is to get your feedback after this webinar as to where we should go next. So do please keep in touch with us after this webinar. And whilst we're not going to take questions right this second, we will take some questions at the end of the session. But as I said earlier, your questions won't disappear into a black hole. So thank you in anticipation for any feedback and comments that you can give us. I've given you a very brief highlight there, and I've tried to compress it into a relatively short amount of time. So thank you very much for your understanding.
Okay, so I think I'm next. I hope you can see my presentation and hear me well.
Yeah, it's all good.
All good. Then I'll start. Yes, for the introduction earlier on, I work for the Norwegian Coastal Administration, and as a response agency, we need to know how to respond to the new generation of low sulfur fuel oil spills. We're interested in how we can improve our response capacities, and also we need a better understanding of potential environmental impacts of this new generation of fuels. This will be a work in progress. I've been asked to talk about 2 ongoing projects. So this is really work in progress, and Cedre will present some preliminary results from one of the projects following my presentation. So I think the background has been highlighted very well by the previous speakers, so I will try to be brief on that. I will briefly touch on some national projects that we are doing in Norway, but the main focus of my presentation will be these two projects mentioned by Paul, the EPPR PAIM project, New Low Sulphur Fuels, and Immerse Project. I will say a little bit about the background to these specific projects, and just to pick up on the statistics parts. This is a more local example from Europe. This is the Belgian petrol balance compared 2019 to 2020. Must thank my Belgian colleagues for providing the data here, but it underlines that there is a significant change taking place from traditional high sulfur fuel oils until 2020, where 70% of the bunker out of Belgium is made up of LSFOs. And this again can be separated into ULSFOs and VLSFOs. And actually what the data is not showing here, but what is in the underlying material is that throughout 2020, the share of VLSFO is increasing and the share of ULSFO is decreasing. So of course, 2020 has been a very special year with the COVID-19 situation and everything, which has impacted the world economy. But I think still, when we look at the totals for the last 3 years, we can definitely conclude that a major shift is taking place towards more low sulfur fuel oils. But I totally agree with the previous speaker that we must not forget that there are still also other things that we need to be prepared for. So our work on this subject started back in 2016 as the North Sea and Baltic Sea became special emission control areas. We expected an increase in the volumes of MGO and ULSFO along the Norwegian coast, and in cooperation with SINTEF, we had a project characterizing and doing weathering studies on MGO and ULSFO. We also have a test basin at the NCA. It's a 7 by 30 meters saltwater basin where we can apply current and small waves. And we tested some of the equipment from our stockpiles on different ULSFOs in this test basin. So I would like to show you an example from this previous project. Testing a brush skimmer in quite cold water into different ULSFOs. So you can see this one, it's flowing nicely into the skimmer. It's quite easy to recover. Everything is working fine. We're not dragging in a lot of water. So this is actually working quite well. On the other hand, there's another product. You can see that one here, and this is a product with a high pour point, so the viscosity should not be a problem for the skimmer. And actually, the pump is pumping the oil. That's not the issue, but the skimmer is actually just digging a hole into a semi-solid oil slick on the surface. So the flowing of the oil is actually the challenge here, and the pour point is really important in this case. Yeah, based on the results from these studies, we saw that we were scratching on the surface of something, and we identified a need for more experience and more data. So this has been followed up in some national projects where we also looked into biodegradation of ULSFO and marine gas oil, shoreline interactions, and currently we are doing a little project on shoreline response where we test the efficiency of different washing techniques. This is a joint project between SINTEF and NCA, and it's about testing methods for cleaning on rocky shoreline involving also different cleaning agents. However, it became quite clear that we cannot answer all our questions alone. So we wanted also to do some international collaboration on this subject. And one of the projects that we have taken the lead on is the project New Low Sulphur Fuels, Fate and Behavior in Cold Water Conditions. This is a project that is hosted by the Arctic Council and funded from there. Both PAIM and EPPR are involved in this project. Most Arctic states are engaged in the project. In addition, some observer states like Germany, China, Korea, and Singapore are participating. And the objectives of this project is to identify the relevant fuel oils, which fuels are used in the Arctic, and also get a picture of the variability, and also, if possible, come up with some recommendation to the oil composition and also with regard to the environmental properties. So this has as a focus on cold climates and also a high focus on toxicity. The project is organized like this. It is project management group, which is supported by the EPPR and PAIM secretariat. And it's also been identified a report drafting group. The work is separated into 5 work packages. For the moment, work package 1 and 3 are ongoing. One is a survey to identify fuel types. Work package 2 is an industry involvement workshop. Work package 3 is fuel oil sampling. Work package 4 is fate and behavior, and work package 5 is toxicity testing. So the deliveries from these separate work packages is actually a questionnaire for the work package 1. I will introduce you a little more to that. This questionnaire is for the time being vetted and evaluated before it will be distributed to a large number of ships. Work package 2, the industry involvement workshop, has unfortunately been delayed due to the COVID-19 situation. But the questions that we want to address in this workshop is why these fuels that have more or less the same purpose have so different behavior, so different properties, and they have also very different levels of toxicity. What are the reasons for that? Is it about the crude oil, the refinery processes, additives? Most probably a combination of this. And are there any means that can be taken to improve the properties, or to say with other words, are there any possibilities with simple means to reduce the potential adverse effects on the environment during a spill? So in this project, different laboratories are engaged, and they need to agree on a common methodology. And this work package is doing great progress. The first draft report on the methodology is finished and is being reviewed and commented by all the partners. When the methodology has been established, one can move on to analyzing fate of behavior of oil samples and also to analyze toxicity of samples. So this is what is planned for, and for the time being, work package 1 and work package 3 are the focused work. So this questionnaire, the idea is to address an invitation to participate in the survey to ships traveling in the Arctic by email or text, and then you will get a link that you can open on a smartphone or on your computer. And if you have your bunker delivery note at hand, you can use that for the survey. So you can actually take a picture of it, and that will be your response to the survey. If you don't, you can still complete the survey by filling in some forms manually. This will be fed into a central database. And you can do the same basically from your computer. You can attach your bunker delivery note or fill in the forms manually, and this data feeds into the database. Then the data will be generalized, categorized, and we will have a data export. It's not about tracking simple or certain bunker deliverers or certain ships, but it is to see what are the main categories that we can expect in the Arctic. Okay, so if you have questions to this project, I will take them later, but I can also direct them to my colleague, Gunter of OSRL, who is managing this project. I will now introduce you to the Immerse Project. The idea for the Immerse Project came up when we presented the results from our national response tests to the Bonn Agreement and the Otsupa working group. And we gathered a group to draft an application for the EU to do a joint project on this, and this was successful, and the Immerse project started 1st of January last year. We have a website for the project. It's not so much information there yet, but when we have reports and so, they will be published on this website. The objectives of the Immerse project is to develop recommendations for oil spill response to these new fuel oils and to identify the best methods for response at sea as well as on shorelines. We also want to increase our knowledge in order to better understand the potential environmental impacts a spill would have. Yeah, 6 partner countries in this project. But we have also been supported by a lot of other entities, and especially from the Netherlands, we've got a lot of data and support. This project has quite an operational focus, and I think personally it's a good mix of authorities and responders and scientists that is a strength to this project, I think. So the project has been organized in 4 different work packages. Well, the first one is project management. Second is compilation of knowledge. The third one is called chemical characterization. However, it goes far beyond chemical characterization. And the fourth work package is response options. This was planned as a 2-year project, but due to the situation this year, we are now working from the perspective of 6 months prolongation of the deadline of the project. We are now well into 2021, and of course the project management goes throughout the project. The second work package with compilation of knowledge will be finished by this summer. We've started the chemical analysis part that will also continue until 2022. And the fourth work package, well, it will start this spring, but the main work will be undertaken this autumn and in winter 2022. And we still hope to be able to have a final stakeholder meeting that is planned at the end of the project at our project partner in Malta, and that will be open also for interested parties outside the project group. Yeah, so a little bit more details on the work packages. Project management, it's my responsibility. It basically speaks for itself. It's planning, meetings, workshops, reporting, finance. But the most important part, I think, is the cross-cutting activities in order to make the work packages fit nicely together and to put all the pieces of this big puzzle together. The second work package is managed by the Royal Danish Navy Command, and here we are looking into getting an overview of what are the most frequently encountered products in European waters. Of course, we are impacted by what's going on elsewhere in the world, but we had to make some, to put some boundaries to our work. So we have taken the approach to interview and send and question European refineries and bunker suppliers. So that is all partners are contributing to that, and also a lot of entities outside the project are contributing to this. And also the acquisition of samples, small samples for work package 3 and large samples for work package 4 is part of this part of the work here. And I think with this project targeting the deliverers and the other project targeting the shipping industry, I hope we will have some kind of good overall picture at the end of both projects. So that's quite a good division of work, in my opinion. So the chemical characterization, I think it has been made very clear how important the physical and chemical properties of the oils are. And we will also look into oil weathering and toxicity in the water column. Identification will be part of this work package, and also modeling. We don't want to create any new modeling tools or so, but we want to make sure that the results from the projects are presented in a way that they can be used in already existing decision support tools, and make some recommendations also with regard to best practice for modeling these new oils. Work package 4 is response options. We're looking at the whole toolbox: mechanical recovery, dispersants, in situ burning, and shoreline cleanup. Mechanical recovery is the main emphasis, and dispersants and in situ burning will be done on a laboratory scale. I perfectly agree that there is already a lot of tools in the toolbox, so we don't have to reinvent the wheel, but the idea here is to identify which concepts work and what are the limitations, identify possible adjustments that can be made in order to handle some of these more challenging products in a better way. It is not about rating one equipment up against another, but to identify the concepts that should be considered. Okay, and finally, sample selection. The idea of the Immerse project is to start with a broad range of samples, and we will soon hear some results of the initial chemical analysis of these small samples that have been gathered in the project. We are now here at 2021. We are seeing the first results from the project, and now we need to take some considerations on how to move forth. Because for the next steps, we will choose some samples to acquire in larger quantities and to test toxicity and weathering and all the response options from work package 4, and especially for the mechanical recovery part, we need some larger volumes to test on. This seems maybe a simple task, but there are a lot of considerations to be made. Of course, the availability of the desired volumes might be an issue, but there are batch variation, blended products, and we've seen that variability is a great issue here. So that needs to be taken into account. And I think as responders, we need to prepare for the whole range of different possible spill scenarios, from the easy recoverable oils to the more challenging ones. So capturing the variation here is really important for the further tests. And with that, I would like to hand over to Cedre to present some preliminary results from the work package, first tasks of work package 3. So thank you for your attention so far.
Okay, can you hear me well?
We can hear you, yep.
Yeah, okay, thank you. Good day, everybody. So, yeah, I will present you the preliminary results of the Immerse Project. So results are coming out from the lab just now, actually. So it's really first observations and first screening of the samples. So during this first step of the project, the physico-chemical characterization, we have collected 13 samples. 2 of them were ULSFO and 11 were VLSFO. They were coming from 7 different countries. They were coming from oil producers and bunkers delivery. Most of them were blended products and 3 of them were solid at room temperature. They all had this very black and dense appearance. So concerning the characterization, we characterize the fresh oils in terms of viscosity and density at 2 temperatures, 5 and 15 degrees, because they are representative of European waters. We also characterized the oils, the fresh oils for flash point, pour point, waxes and asphaltenes content. We did an OSRL characterization, that is a detailed chemical composition of the oils. We measured the evaporation rate thanks to distillation at 250 degrees. And finally, we did dispersibility tests.
Sorry to interrupt, Fanny. I don't think we can see the same slide, the second slide.
Okay.
You can just see your presentation. I think we just see the first slide now.
Okay. Up. Let me try to.
There we go. I think we're on your slide now.
Is it okay?
Yeah,
if
I think I put it into presentation view.
Okay, it's okay now?
I think it's in edit view. If you want to just put it in presentation view.
Yeah, it is actually.
Oh, okay. We may need to share another screen.
Is it okay, this one?
Perfect, success.
Yeah.
Thank you. Sorry about that.
No, it's okay. It's me, sorry. So, yeah. So we decided to add, to carried out additional tests compared to the initial ones. It means that on the residue that we had from the evaporation, we decided to characterize also this residue in terms of viscosity and density still, and also in terms of pour point and dispersion. This sample is actually really important because it approximately corresponds to the maximum evaporation at sea. And additionally to that, we also tried to form emulsions from this residue with 50% water content. And here again, we decided to characterize it in terms of viscosity and density and dispersion. So actually, with all this data set, we can have a good estimation of the behavior of the oils, their weathering, and it can give good insight of response strategy. So here is one of the conclusions actually of the SINTEF report, where they had worked on 3 different LSFO, and the conclusion was that they showed a wide span in the physico-chemical properties that likely reflects the different recipes to comply with the new sulfur limits. So our objective here was to try to collect the sample group as big as possible in order to enhance our knowledge on those products. And so as a first result here, you can show 9 GCFID chromatograms of the 13 products. The GCFID chromatograms are used as a screening, they used as screening the samples, and just based on visual comparison, it highlights the difference and the major differences between the oils. So for those who are not familiar with this kind of graphs, on the x-axis here you have the retention times, and so compounds with low boiling points, so light compounds are located on the left part, and bigger or heavier compounds are located on the right part of the graphs. On the y-axis you have abundances. And so you can see that all the narrow regular peaks here are N-alkanes, and the irregular peaks that you can see here are the naphthalenes, aromatics. So actually, each narrow peaks correspond to a fixed number of carbon, and a fixed number of carbon. And so the red dashed line here on the left part, it is all the compounds with less than 17 number of carbons actually. So you can see that some oils just do not have light compounds, while other ones are just full of higher alkanes. This brown dashed line here corresponds to the compounds with more than 20 carbon atoms on the right part here, and so it corresponds to wax component. So it's the same. You can see that for some samples you have quite a lot of waxes, and for other ones you do not have waxes. And what I should also say is that the limit of this analysis is that with GCFID, you cannot measure the very heavy compound because it stopped at around 35, 36 carbon. So it means that actually here you are missing one part of the analysis. You do not know if you have huge amount of heavy component on the here, and so it's those graphs just allow to screen and to see the different patterns of the oils, but they cannot explain by themselves the total behavior of the oil. So it was just in order to see that oils are definitely different. Now, if we focus on the wax and asphaltenes, here are represented the waxes and asphaltene contents of 12 of the 13 samples. We are still waiting for one result. And so you can see the high variability actually just on those 2 parameters. Asphaltenes are ranging from 0.4% till 4%. While waxes are ranging from 5% till 26%. We have overlaid the Immerse dataset to the Cedre internal database that we have on around 80 samples. So the blue dots here are products already studied at Cedre. They are mainly crude oils, but not only. And it is just we decided to show this graph just to see that Immerse samples are kind of lost in the middle of the crude oils, I would say. So actually, yeah, the LSFO are very, very variable. We have added here two samples from the SIMTEF studies that are the heavy fuel oils. And those points just allow to see that maybe the LSFO are in majority more waxy than heavy fuel oils, and maybe they have a bit less asphaltenes than heavy fuel oils. But I think the most important point is just to see the variability of the samples. Concerning the density, so we measured the density at 5, at 15, and also at 20 degrees of the samples. At 15 degrees, density is varying from 0.9 till 0.98. And when the temperature decreases, the density is logically increasing. So compared to heavy fuel oils, we can find some quite light products in the 13 samples we have collected. For viscosity, it is the same. We have quite a lot of variability of the samples. At 15 degrees, viscosity is ranging from 375 millipascals second till more than 6,000. And what we noticed is that when the temperature is decreasing, the viscosity highly increases. In terms of evaporation rate, we can see that here again we have variability between products. Evaporation rate is ranging from nearly 3% till 28%. So compared to heavy fuel oils, some of the products here have exhibited quite a high evaporation rate actually. And so what we can also say is that for most of them, the evaporation rate is under 10%, and so for some products, it can conduct to some persistency issues at sea surface if a spill occurs. Few words about the flash point. All the flash points were above 60 degrees. The minimum was at 78 degrees Celsius. So in terms of safety, recovery operation or uses of dispersion from ships could be conducted directly after the spill. There is no delay to wait before intervention. Now, concerning the pour point, it's probably the most surprising results. We were not expecting such variability and especially such low value. You can see that pour point is ranging from minus 27 degrees Celsius till 30 degrees. So we were expecting quite high values. And we are a bit surprised when we see the results from 3 of the samples at least. I should say that when there is no bar here, it's that it is 0 degrees. So for 3 samples, it is 0 degrees. So yeah, we have to show that more in detail. What we can say is that the samples with the highest pour points are related to the sample that are the more waxy. So it's what we were expecting actually. And here I introduce a few data that we have collected on the residues of the 250 degrees distillation. So what we can see is that it is actually for the samples that had the initial low pour point that the variation between the fresh oils and the weathered oils are really the most important. And actually for those 3 samples, the evaporation was also quite important. So it's linked to the evaporation rate. So yeah, I think those results are important in terms of insight for response strategy. What I can say too is that from the weathering we have done at the lab scale, once topped at 250 degrees Celsius, oils are becoming highly viscous. So the viscosity increased a lot, and even more than viscous, some oils were just becoming sticky, really sticky. So some viscosity at 5 degrees could just not be determined with the viscosimeter because of really too sticky products. And at 15 degrees, viscosity just increased at very, very high value, up to 250,000 millipascal second. So yeah, we encountered for some oils, not all of them, we encountered some troubles at the lab for the measurements, but also for the cleaning operations. And to illustrate this point of difficulty for the measurement, I would like just to finish on one slide of results. So here are presented data from the dispersibility of the fresh oil. So we have chosen to do to carry out an IFP test that mimics low energy at sea. And only at 15 degrees using a non-commercial dispersant, that is the dispersion model. The idea was just to have an idea of the dispersibility, because of course in the next step of the project, when we will do the selection for the 3 or 4 products that will be weathered at a pilot scale, we will do a more detailed and more deep study on the dispersibility using different tests, IFP and MNS, and using different dispersants. But still, here it was just to have an idea of the dispersibility of the test. And so you can see here all the samples, and on the y-axis it is the dispersibility in percent. And the 2 blue lines here at 20 and 50 degrees percent, sorry, they are here to see if the oil is dispersible or not. Below 20 degrees, the oils are considered as non-dispersible. Above 50, they are considered as dispersible, and between 20 and 50, they are potentially dispersible. And what I want to say is that usually we are doing duplicates for testing dispersibility, and the 2 duplicates have to be very close in terms of value. If we are going, if the difference between the 2 samples is too important, we have to carry out a 3rd test, but it does not happen often. Usually with two measurements, it's okay. And as you can see here, we had to do at 3 different measurements for some samples, and even three measurements were sometimes not enough to have a good value, because I guess it's because of the wax, important wax fractions that are in some oils. Even if we put the oils in the oven overnight, even if we try to homogenize as much as possible the samples, I think that we have some differences between the subsamples that we are measuring. So anyway, what I wanted to show you also on this slide is actually some oils could be dispersible if spilled at sea. So maybe it's a response strategies that we have to look for, and maybe it can be used, yeah, actually. And this was just for the fresh oils. Results from the weathered oils are still in progress, but the first results is that oils dispersibility decreased quite a lot when the oils are weathered. Okay. And so to conclude, I would say that, yeah, definitely there is a high variability in the physicochemical properties of those oils that maybe reflects, yeah, the different recipes. For some oils, a high degree of persistence at sea is expected. Some oils also exhibit very, very sticky behavior that can be difficult to handle in terms of recovery. The use of dispersion may be limited on some oils, but could work on other ones. And we should say that, yeah, definitely some oils are very viscous, not easy to work with, and but I think that some other oils looks more easy to handle and looks less viscous and maybe are dispersible. So they are not all very difficult products. And so now the next step for us in the Immerse project is to discuss all those data more deeply and to decide which oils will be tested then for pilot scale weathering and ecotoxicity. Yeah, so that's it.
Thank you very much, Fanny. So we do have a few questions that we have some time to get through here. There was one about pour points. I think this is one maybe for you, Paul. Pour points increases rapidly after weathering. Why did you select 21 degrees as a temperature of interest? I think we would be interested to look at oils with PP of 10 degrees Celsius or even 0 degrees, considering expected increase after a spill in typical ocean temperature.
Yeah, to be honest with you, it was a case of taking what data we had available. The data that we got from VeriFuel was obviously collected for a different purpose. It was collected to look at compliance with the ISO 8217 specification. So we kind of have inherited and got what was available. I do have some information that is at lower temperatures, but in many cases it's just reported as less than 21. So it's not something that we specifically selected or requested. It's the way it was actually given to us, and obviously we can only use what is available. In an ideal world, I'd have had it at every 3 degree point below 21 degrees, but that's simply not available from all inspectors. So we've just used what was available. I noticed that Per Darling has asked us a similar question. We do have some data, but it's incomplete. So some inspectors, some locations have given me data at lower temperatures, but it doesn't give a complete picture. So yes, I have some, but it's a case of making the best use of what we had available, which was collected for a different purpose, unfortunately. So we're hoping that the results from what the NCA and what Cedre is doing will give us some more data that we can correlate with the VeriFuel data.
Okay, we had another question from Gary. Would it be reasonable to have, I think this is for you again, Paul, would it be reasonable to have producers and carriers provide response relevant oil characteristics in addition to basic information? By what mechanism can this be accomplished?
I mean, again, that is a very good question, a question I've wondered about, and to be honest, I don't quite know what the answer is. All I know is that the ISO 8217 doesn't necessarily give us everything we want. So yes, we get a viscosity measurement, but that's only at 50 degrees C. Yes, we get a pour point measurement, but it may not be an actual temperature. It could just be a less than temperature. So I think it's a good question. I don't quite know how we get the information we need, because I think clearly from a response point of view, it's one of the things that we want to know as soon as possible, so that we can start pulling out the right tools from the toolbox. So I'm not quite sure what the mechanism is, but it's something that we do need to consider going forward.
Okay, and this is another one that's for both you and Celia. Has the NCA or OSRL tested a star disc type skimmer, example the Camara Star or Sea Devil, in the higher viscosity VLSFOs as well as the brush skimmer? If so, what are the results of that trial, noting that the brush skimmer dug a hole in the oil?
Maybe I should answer that. In this specific project, we have not, but we are aware that there are products out there that might cope better with this actual problem. This was our initial work on it, and I think that is also a little bit the aim of the Immerse project to identify what concepts would actually handle the specific challenges that might come from the oils. So we haven't done so, but we would work further on along that line. So thank you.
Okay, and the next one is, it's clear that difficulties on response in the case of low sulfur fuel oil, marine oils spills are also due to high variable relevant properties, for example, viscosity. In your opinion, is it possible to cover partly these gaps by the request of more accurate physiochemical data about low sulfur fuel oils in the onboard certificates and documents?
I think that's kind of touching on the similar point to the point that Gary made in his question earlier. So basically, I think what we're seeing is that, yes, they are very variable. And the question is, how do we get more information on the specific product at the time of the spill? So I think that's what the question's saying. And I think that's similar to what Gary asked earlier. It would be great to be able to get that additional information, but I'm not quite sure yet what the mechanism is. Celia, Fanny, do you have any particular take on that one?
No, I agree with you. It would definitely be desirable to have this information, and from our point of view, we've also discussed this previously, if there could be done anything about regulations and so on, but for the time being, we have this large variability, but I think that all this information that you have gathered and that we will gather in our project, it will at least bring us some closer to maybe group the oils and so on. But of course, the availability of this data is one point, of course.
Okay, thank you. And how many products do you hope to test in the Immerse study, given the earlier part of the presentation describing the large range of properties of these fuels? I think that one's for you, Celia.
Yes, we hope to test 3 or 4 different products, but it is some considerations that we need to make. Do we want to test do a few tests on a lot of oils, or do we want to pick some of the extremes maybe and test more different equipment types or with other variables? So this is like adding up. So it's a discussion we will have in the project. What is most important to test? Many different skimmer concepts or many different oils? But I think we have aimed at 3 or 4 different oils.
Okay. And did the GC-FID analysis capture B texts?
Sorry?
I think that was one for you. Did the GC-FID analysis capture B texts?
Sorry, I don't understand the question.
I'm not sure either. Paul, do you know what that one's referring to?
I think it refers to the chromatograms that Fanny was showing, and I think the question is whether that would pick up the monoaromatics, benzene, toluene, ethylbenzene and xylene. So I think it's just asking whether those chromatograms would actually pick those up as separate sort of species. That is my take on it. Celia, is that your understanding? If it's not clear to Fanny, maybe that's something we can pick up afterwards, maybe rather than scratching our heads now. But that would be my take on it. But maybe we can chat with Fanny afterwards.
Yeah, I can just say that they are not visible on the GCFID, but we measured them. We have data from that, but yeah, they were not visible on the GCFID. It's true. Yeah.
We have another question from Mohammed. I think we have time for a couple more. I've noticed that most of the work being carried out on taking into environmental conditions of European and Arctic waters. Is there any research as regards the conditions and temperature environments such as the Gulf of Guinea or the Atlantic Ocean?
I'm not aware of any, if I'm honest. That's not to say there isn't anything out there. I don't know whether, Celia, in your circles, you're aware of anything.
Not really, because well, we're based in Norway, so we're looking at the cold water climate conditions, and the Immerse project is looking at more temperate, so we're testing at 5 and 15 degrees, but I'm not aware of any work that's been undertaken to address warmer climates. No, I'm sorry.
Maybe that's something we can look into after this call, just to see what else is out there, because I'm sure that other work will be ongoing, but maybe we can try and pick that one up afterwards for Mohammed to see if we can find anything out.
Okay. Jackie says, Fanny, great talk. When will the results of this project be available, and will you be able to share the detailed chemical data?
Yeah, so I think Silje, you mentioned the calendar. I don't know exactly when. I think the whole data set will be published and public all together at the end of the project.
Yes, but we send also some smaller reports on the progress to the EU, and I think they are also to be made public. But of course, the complete results will first be available at the end of the project.
Yeah, and I think the first report is not only the physico-chemical characterization, but also the weathering. So it means that this report will be the addition of this part plus the selection of 3 or 4 oils that will be tested at the pilot scale. So it's a matter of few months to write the report after. Yeah.
Heyo asking, is the range of variability between VLSFOs similar to the range of variability between HSFOs? If higher, would that warrant or mandate a change in overall response preparedness strategies?
So between ULSFO and VLSFO?
That's yes.
Yeah, there is nothing really clear. No, there is no one group with results of ULSFO and VLSFO. No, nothing. 2 of the 3 solid samples were ULSFO. So on the physical aspect, yeah, the 2 ULSFO were solid. But after, with all the other parameters, there is nothing clear between the 2 groups of samples.
Okay, great. And I think that's it for questions, isn't it? So yeah, if anyone had any further questions, they could let us know at my OSRL at oilspillresponse.com, and we'll forward that question on to one of the presenters. This presentation will be available, as I said, on our website, and it'll be sent out by email to everyone who registered. So thank you so much for everyone for joining us. Thank you to our presenters, and I hope everyone found it informative and enjoyed it.
Thank you very much.
Thanks very much, guys. Bye-bye.
Thank you. Bye.